So now I'd like to turn to Dr. Lim.
So he'll be talking about the autonomous surface ships that will be operated by software. And but would there be any technological challenges that we have to overcome to ensure the right operation of these ships? And as we go for digitalization, autonomous navigation has emerged and has become very important. And we have some autonomous ships that are already being developed, but their versions are just 1 or 2. But then we have a company that developed 3rd or even 4th versions of this mess. So in that sense, Mr. Lim Dohyeong, CEO of Avikus, will give us a presentation on the state-of-the-art technology. He joined the Hyundai Heavy Industries. And for a long time, he worked in a digital research center for shipbuilding industry. And then he established his own company called Avikus. So for the disasters software, the navigation software, I heard that he sold out these 300 copies of these softwares. So I believe if you could have an opportunity to invest in this company, I believe that you will be able to enjoy a lot of returns. Anyway, so we would like to invite the CEO, Lim Dohyeong of Avikus, to the stage. Thank you very much for your kind introduction. So, Avikus, we are not a software company. We deal with both software and hardware. In order to provide the autonomous navigation solution, we have to have a well-integrated business that combines both hardware and software. I would like to briefly talk about our business and our company. Here you can see the content of our presentation. So I will introduce to you one of our solutions. And also for the autonomous ships, for the autonomous operation, what are the challenges that we have to overcome and consideration we should make? So this will be my presentation. And here you see MAS. MAS stands for Maritime Autonomous Surface Ship. This is based on the IMO definition. And so we don't include the underground ships, we only include surface ships. And IMO has these 4 stages. So the first stage is about to support decision making, and second is to support control. But so remote control is possible, but people have to be on board. Seafarers have to be on board so that they can be involved anytime during an emergency. And the phase 3 and phase 4 are where there are no human operators. So the third phase is a full remote control, and the fourth phase is a fully autonomous ship. So these are the 4 phases for MAS. And these phases are defined by IMO, but somehow the concept of the remote control and autonomy are mixed, and therefore IMOs are now redefining these 4 phases. But based on the current definition of the 4 phases, I will make my presentation. And I believe that we are actually in phase 2, so we are not producing the full autonomous ships. Rather, what we are producing right now is a digital support system like the ADAS for cars. So the remote control system where human intervention can be made anytime during an emergency. So why do we have to invest in MAS? In fact, onshore, we have the autonomous navigation technology, and why not applying that for the offshore setting? As you know, 80% of the human-caused accidents can be reduced. So only 20% of the accidents can remain, which means, and also globally, we we will have a labor shortage for seafarers because of the demographic aging. One of my employees used to be a seafarer, and he was on board for 6 months in a row. And so in the end, he gave up his career and he joined my company. So I think that more and more young people will avoid this job and we will continue to have a labor shortage. So this necessitates the automation. And also, for example, like if you overspeed and if you run a car at overspeed or if you run a car at full speed, the cost will be very different. And so if ships are become fully autonomous, then it can effectively reduce the relevant cost, and it can also cause some ripple effects. Now let's take a look at the current status and what we have developed so far. So in order to realize the mass, everything has to be automated, not just the navigation system, and also we have to have a strong support system and backend system. So including navigation for various sectors, we have pursued the automation technologies. And here you can see the commercialization and the realization. So for the component automation, we achieved more than 100 kinds. Although partially, but we have continuously pushed it forward with the automation, and our ultimate goal is to enable full automation and full autonomous operation. And we are currently developing the solutions for the merchant ships and navigation assistance system called the HINAS. So this is the sort of the marine version of ADAS system. So ADAS refers to the Advanced Driving Assistance System, and so ADAS enable cars to adjust the car lanes, and also during the car accidents, it enable car to make a sudden stop. So it's a very, very convenient solution. One of my employees said that if you compare the post before and after riding on the Tesla, he says that the Tesla does not require any kind of human labor or human driving. Anyway, so our solution provides the situational awareness, and also we have a solution which provides the 360 around view, real-time view. We also have a collision avoidance control and route optimization solution. So let's first take a look at the situational awareness. That we have 3 optical camera and 3 IR camera. So using 6 cameras, based on the AI deep learning technology, we can automatically detect ships that are coming. And also, since we work with the shipbuilders, so for the 3 shipyards of the Hyundai, we have offered our technology as standard. So they recognize the excellence of our technology, so they adopted our technology as standard. And already we have 40 installations, and data keeps coming from them. And based on these accumulated data, we have a huge database of the marine data. And based on that, we continuously advance our deep learning technology. And here you see the IR camera. So even at night, using the same algorithm, we can detect not just the vessels and ships, we can also detect the buoys. And also, we have to have a far-sighted view, and therefore, we also use sensors in order to have a more comprehensive situational awareness. And based on situational awareness, we make decision, we provide control. This is the 360 real-time around view control. So we not only have 2D, but we also have a 3D view. So you can have a 360 real-time monitoring for the entire vessel in order to avoid the blind spot. And you can have this wide view with the tablet, so which means that this portable device can go with you anywhere you want. And next is a control solution. So one of our advantages is that you don't have to change your existing infrastructure only with our solution. If you have one laptop and you just connect it without solution. And if you have autopilot function and engine speed control, so with these two interface, then you can make full use of our solution. And this is the collision avoidance solution. So based on the situational awareness, based on our vision technology, our solution offers the way to avoid collision. And we have various simulation solutions as well as the simulator, and they have been demonstrated. And also together with the shipbuilders and shipping companies or carriers, we have engaged in various demonstration projects. Route optimization has been with us for the past 10 years. And what's different from our solution is that it does not require manual setting. Otherwise, you actually have to input a lot of parameters, which could be very, very cumbersome. But here you see, once you define the policy by default, then all these things are automatically applied. And this could lead to various additional effects. So this could improve the fuel efficiency by 7% and reduce greenhouse gas emission by 5%. And our solution, because we have a control solution and therefore safety is at the center, and we have conducted and performed various studies together with the Korean Register and other companies, and we have received the certificates and approval from the various registries. But as I said earlier, when many people ask me, when will the full autonomous ship be arriving? So the technology will continue to be developed, but I think we may have to overcome various challenges in order to realize our vision of full autonomous ship. So we have taken stepwise approaches to tackle these challenges. So here you see that we have received about 350 orders, and 40 of them already have been installed. And also our technologies have been adopted as a standard for new buildings, for new shipbuildings. And also our solution only requires interface, and therefore it can be connected not just for new buildings but also for retrofitting of the existing ships. In order to secure technology leadership, we have conducted the various tests for autonomous navigation. So we established the company in 2021, and in Pohang there is a canal about 10 kilometers long. So we used the 12-person boat and mounted the full autonomous navigation system on top of the boat and did the demonstration together with KAIST. And this demonstration project began from the US, and the ship will travel to Dohyeong in Korea. And for 305 hours, there was no human intervention. It was solely the autonomous navigation, and also with the efficient driving, we were able to reduce the carbon dioxide emission by 5% and improve fuel efficiency by 7%. And this refers to the demonstration session that we did during the motor show. So here you see that the objects that are recognized by cameras, they are depicted in the 3D screen. And so vision-based detection, as well as the collision avoidance and slowing down of the speed, all these are controlled in an automatic manner. And even the auto docking and 360-degree real-time monitoring. So you see that it's just like a ADAS for vessels. So we showcased this technology during the Cannes boat show. And already the technology has been commercialized for low-end ships. And this year, together with the Busan City, we signed the MOU for water tax. So this year, you see that this is an electricity-powered water tax. We developed this together with the Busan City, and we did the autonomous navigation test. and we will embark on the actual water taxi project from 2025 with the city of Busan. So you see that we have continuously advanced the autonomous navigation technology for mass. But in order to reach the level of mass, there are still a lot of technological barriers that we have to overcome. In particular, for phase 1 and phase 2, there is almost no conflict with the current regulation because human intervention can be made anytime, and therefore technology development itself is not that difficult. But once you reach level 3 or degree 3, there will be no human on board, and therefore you have to provide the product liability, and also you have to develop different kinds of autonomous navigation technology for different kinds of ships. So these could be pretty serious technical challenges. And also for fully autonomous ships, I believe that it will take a lot of time in order to see the realization of such ships, and regulations have to be developed, which will not be easy. But in order to achieve higher degree of autonomy, then what are the barriers that we have to overcome? So first, there could be the technical barrier. We also have economic, regulatory barriers, as well as barriers in relation with social acceptance. So let's delve into technical barrier. For the autonomous driving car, from 5 years ago, people said that the level 3 car will soon come out, but that has not been realized yet. Why? Because there is an issue of the social acceptance, but also when it comes to the cornering issues, the AI is not sophisticated enough to deal with this issue. And also for the automobiles, we talk about V2X. So social infrastructure is very important. Right now, all the traffic signs and everything is based on human traffic. But for the autonomous driving car, all the banners and systems have to be changed. And the same goes for the shipping. So the infrastructure has to be established. And also for phase 3 and phase 4, it will be very, very costly, and therefore we have to find out solutions to reduce economic barriers in order to lower down the capex and opex. And also there could be a barrier of social acceptance. There is a saying that in order for a new system to be adopted, then its performance should be 10 times higher than the existing system, and the reliability should be at least 5 nines. So in other words, the reliability, acceptance, and trust, these are also very important that have to be earned. And regulatory barriers are something that we should tackle as well. And it cannot be handled single-handedly by one entity. Rather, whole industries have to come together based on the consensus. And regulation can truly be a barrier that stumps the development of technology, and therefore regulation should be made in a positive way that can promote new technology development. So autonomous, full autonomous ships, these are sort of the unprecedented novel solutions that we have to develop, and therefore only with a single industry we cannot achieve this vision. Rather, we have to build a consensus, and rather than being engaged in competition, we have to promote cooperation and join our hands together. And with that, thank you very much.
예,
Thank you, Dr. Lim, for your insightful presentation. Please give him another round of big hand. As I mentioned, Mr. Hatzigri Goris made such a fantastic presentation. I think Mr. Lee was under so much burden. Sometimes he caught me offhand with new surprising and innovative technology. What a relief for me. And autonomous ships are very popular. That's a very popular topic in the world, and that this is such a sophisticated and complex, complicated technology. And on inland, you have coordinates you can follow, but the marine environment is completely different from that land environment. That is why this is quite tough to be realized. When we started this business, we were not entirely certain whether this is the right direction. We had a vision, but we believe that we have the sufficient capacity and resources when it comes to the soft skills and hard skills. So although we had to start from scratch, we embarked on this journey, and thanks to this adventurous spirit, now we are aiming at technology which will sustain us for the next several decades. As will be briefed upon during the panel discussion, the full automation of vessels was envisioned for the next 20 to 30 years. But now it feels as if we have to apply this technology right away. Dr. Lee and Mr. Hadze mentioned all the technologies being developed in the shipping and shipbuilding industries are moving and geared toward decarbonization and net zero. I think that is why it is imperative for us to work harder. Now I'd like